And here's the DGX Station here, the Nvidia. And who are you?
Hi, I'm Marcus Weber. I'm actually the product manager of that DGX Station.
So that looks like the most beautiful desktop in the world. What is this?
It's absolutely beautiful. I think so too.
Why do you make it so golden?
That's a design feature. So it just looks beautiful. Inside is all black, very nicely laid out. It essentially packs 4 of our most powerful compute GPUs.
So I'll just go right here. So the most powerful Nvidia GPUs right here. This is the 1080. What is this?
It's a V100.
V100. So that's above 1080?
Yes. It's a Tesla from the Tesla product line, which is specifically for data center compute. 4 of them, and the new Volta architecture, the V100.
So were you already showing this and talking about this at Computex in June, right?
That was in Taiwan, Computex in Taiwan. Yeah, we did.
Since when is this shipping?
So we actually announced this in May this year at our own GTC conference, and now for about a month or so we have been shipping the systems.
So you got 4 GPUs. What else is in here?
Right, we have a very high-end Intel 20-core Xeon CPU. Yeah. We have 256 gig system memory. What's also special about is that those 4 V100s are connected with NVLink. So it makes them being able to talk to each other much faster than just over the PCIe bus. And of course it's water cooled. So here we have the water cooling system that really keeps the GPUs nice and cool, and therefore the whole system extremely quiet.
Quiet. So is this for supercomputing guys to sit and do supercomputing development?
Exactly. So it's both for deep learning training workloads, first of all, but you certainly can use it also for GPU accelerated HPC workloads.
So what's the price?
The list price on it is $69,000 US.
So do you have many customers already?
We have many customers already. Of course, I can't tell too much about that.
They're like all like the high-end supercomputing employees of the world, right?
So all the deep learning research institutions around the world, a lot of healthcare customers, automotive customers have this already, a lot of the big universities.
So this Volta, how much of the Volta are you talking about in the booth here?
Pretty much, maybe every booth is somehow related to Volta. That's our new chip architecture, right? The latest and greatest. That essentially tripled the performance since last year when we launched Pascal.
So can you maybe 1 or 2 highlights? Where would you show? Should we look over there?
Sure, this one. So,
yeah. So what are we looking at here?
This is the DGX1, so this is the server form factor of our DGX product line. This has actually 8 of the greatest GPUs in it, the V100s.
And this is the one?
This is actually the actual GPU, exactly.
So it's just a GPU with what is going on?
With GPU memory right next to it. And this is the form factor that goes into the server base. So you can see 8 of those here. Those things you see here, of course, are the heat sinks that keep them cool with air. So every chip is basically mounted underneath those heat sinks.
All right. So if I go right here, what are you talking about here?
Well, there you probably should start asking other people, to be very honest.
Ones that are cool to look at?
Yeah, I mean, we have a running DGX station over there.
Let's check it out.
With the room. And then you can download the run Nvidia Docker run. When I get those,
so this guy would be perfect for that.
But if it's so right up about like the size it's trying to do, absolutely give us some indication because
Let's jump over there. And maybe
I can't tell much about it.
We need to try to pull him over. Do you want to talk on video?
I talk about your own system.
Do you want to talk shortly about it? Yeah? So hi, so who are you?
Hi, I'm Ryan. I'm Ryan from Nvidia.
So what are you doing over here?
All right, so this demo station, we're going to be running the same demo that we ran for Jensen's keynote. We're showing off our new HPC containers. And so this example, we're going to be running the NAMD molecular dynamics code from the University of Illinois.
So when was that keynote? Is that which keynote?
That was earlier Monday. So Monday at 3. Don't worry, you can find it on Livecast.
Yeah. So what is it about? What does it do?
Yeah. All right. Well, maybe we should jump in there and. So
maybe you can stand right there.
Okay. Because he's kind of going through it. Maybe we want to come back and do this when I can.
Yeah. So he's basically what's it called? Just because I'm filming in 4K 60, I have a hard time editing this. It'd be great if we can try to
just one shot it.
Show something.
Okay.
Try to explain what he's doing.
When he moves, I'll do it. How's that? Okay. You're doing 4K?
Yeah, 4K 60.
Oh wow.
Yeah. In fact, this is one half of a DGX server. Sure, go right ahead. But yeah, so this.
So what's going on here on the screen?
Let me just get it up and running.
And the DGX server has 8 of them.
Okay.
8 voltas.
Okay. So today we just announced that we were distributing HPC container apps on our NGC Cloud registry. So along with our deep learning frameworks that we have here, we now have HPC applications: Games, GrowMax, LAMP, NAMD, and Orion. These HPC apps, just like the deep learning apps, very complicated, difficult software to install and manage yourself. So we put them in containers, and containers makes life easy. Containers are really cool.
Is it something to do with what do you call it? That container, no, I forgot the name. Sorry, I'm
Docker?
Docker. There's Docker. And,
So this is a Docker container registry, and all you do is you choose to download the container. So you sign up, you get an API key, and then you download the container to your system. And so here we started up the container in this window, and we paused. We paused waiting for a connection. Now we're going to connect this other molecular dynamics simulation we're going to connect the visualization for the simulation to the container that's running the simulation. And we're going to now visualize the molecular dynamics in action. So this is an HPC container running the simulation. This is the visualization connected to that, showing it in real time. And so you can see it if we, you can see the molecules vibrating a little bit. So the idea is we want to run this for a long period of time and understand the dynamics and why the protein is as stable as it is. The last point I want to make, this graphic, that's actually it. That's all I got.
That's all you got, yeah? But what are they doing over there? Is it all related with the V100?
Yeah. Yeah, so this simulation over here.
Is that in space? Is it in brain?
Yeah. It is in space. That's looking at the entropy field of a supernova before the supernova event happens. So a supernova is when a star collapses into a black hole and just crazy happens. They're like one of the more unique astrophysical events in the universe. And so this is a simulation of the entropy field. And this is a massive simulation that they've run. And now they're using containerized visualization frameworks to visualize that result.
Cool.
Yeah.
And right over there, they're doing stuff with cars.
Let me look at that one.
Aerodynamics, maybe?
Let me check that one. I don't know that one.
It's just, sorry, I'm putting it in the spot, but there's a whole bunch of stuff.
Oh, this is, who's doing this one? Do you want to talk to these guys? Because I don't know this.
Do you want to be on video? Can I ask you? Okay, cool. Thanks a lot.
Yep.
Thank you. So what are you showing here?
So this is ANSYS Discovery Live, and this is first of its kind. And what we show here is the CD design simulation. This sort of couples the design tool and the multiphysics simulation very tightly. So by that way, one could sort of really explore a lot of designs. For example, in this case, we could create what-if scenarios like I could just end up creating another copy of this whole truck.
So is it about aerodynamics of cars or no?
Yeah, this is external aerodynamics, and what you see is a velocity plot here.
So is this only possible to do on Nvidia hardware?
Yeah, this is like completely built on CUDA platform, and it runs only on Nvidia GPUs. So it won't run on CPUs, it won't run on AMD GPUs, it's only on Nvidia GPUs.
Why? Why won't it run something else?
Yeah, because it's all on CUDA, built on top of CUDA.
So it needs tons of GPU.
Yeah, at most it uses 2 GPUs in this case, one GPU for visualization and another GPU for compute. But you could also end up doing both compute and visualization in a single GPU if that is what is necessary.
Nice. So is this an app? What is this?
This is called Ansys Discovery Live.
And made by Nvidia?
The app is made by a company called Ansys, but they sort of use our Nvidia technology.
Nice. And what's over there, do you know? Developer zone.
Yeah.
So they have stuff going on with developers?
Yeah, probably. I'm not sure what exactly they're doing.
I'm going to go
I'm going to introduce myself. I'm Mike Cooper. I'm PR guy for Nvidia, so I just wanted to, I won't be on camera. Hell no.
You cannot be on camera, are you sure?
Yeah, no, you don't want me on camera.
Over there,
Yeah,
I
can get you to people that
Can you introduce me over there?
Yeah, absolutely.
Is it okay if I film while I'm walking?
Oh, that's not my car.
Yeah. Let me go over there. People are queuing up for the Nvidia juice. What is this? Something going on here. Sorry, can I jump in here? Yeah. So what kind of stuff is going on around here? Do you know if somebody can talk about it? People are using computers. Oh, sorry, I'm just checking this.
Yeah, but I mean, they probably
I'm just going to check over there. So AI, HPC. And this is the Twitter feed. Sorry, can I just try to film them?
I'm sorry? Yeah, so you can, if you get close to one of the windows, you can actually reach out and grab it using the trigger. Yeah.
That's cool. Alright, it looks like.
This is you guys.
So hi. So who are you? And what are you doing around here?
Sorry, my voice is kind of dying. My name is Mark Ebersol. I'm a training platform engineer. I run the training platform that the Deep Learning Institute uses to teach people how to do lots of really great things with deep learning and CUDA and OpenACC.
So teaching people how to use AI?
Deep learning, CUDA, OpenACC, basically how to solve their challenging problems with deep learning or CUDA or OpenACC or any of the other technologies that are accelerated on GPUs.
So during this week, people are going to be doing that on this computer?
Yeah, so DevZone, these are our self-paced labs. It's somewhat buffet style. You come in, you sit, you choose the lab you want to work on, and they're all self-paced. You work through at your own pace. And then we have experts in our Ask the Expert area who can come and help you with your specific problems in your code.
All right. Developer zone, and it's something that happens the whole year, not only during the show?
So yeah, we do trainings all over the world at all our regional GTCs. We do the trainings at Supercomputing was actually the first place we did this developer zone. I think it was Supercomputing 12. And we've been doing it every year, and it's always popular. It's a great way to get free hands-on training.
So how hard is it to develop on supercomputer?
To develop on a supercomputer? Well, there's a lot of really challenging problems on supercomputers. Our tools try to make it as easy as possible to get started. You know, OpenACC is a great way to take existing code and accelerate it with just a few compiler hints. Deep learning is a great way if you have lots of data to go and start training on how to solve those problems. And then CUDA is really when you need to get in and fully optimize your code to run on the GPU.
So the developers that can do supercomputing are kind of like the top developers, kind of?
Yeah, it's a great crowd here at Supercomputing.
Like you need to be an advanced developer to understand all this stuff, or?
No, our getting started with CUDA labs, our Python labs are all very easy to get started with if you have a base understanding of the language.
And then all this stuff works on all the Nvidia GPUs, not only on the top end, the V100, right?
Yeah.
All those gamer GPUs.
Yeah, like these laptops themselves have gamer GPUs in them, and you can write, the same deep learning code you're running on a supercomputer, you can run on these laptops. Obviously, it doesn't run as fast because it's not quite as a high-end GPU, but you can still develop locally and then go deploy on a big supercomputer.